Alright, let's talk about trapezoids. So our trapezoids in our quadrilateral properties here, they are kind of set aside from our parallelograms. Okay, they are not considered parallelograms because they do not have all of these properties. Okay, say they don't have opposite sides parallel, they are different completely here. So in our trapezoids, we have one pair of opposite sides parallel. Those are called our bases. Okay, and we still have consecutive angles that are supplementary because we have parallel sides here, parallel bases. So we still have consecutive interior angles, and they're going to be supplementary. We'll talk about mid-segment, and then we have our isosceles trapezoids down here. So they have all of the properties of a regular trapezoid plus additional ones here. In a non-isosceles trapezoid, so this is a four-sided figure with one pair of opposite sides being parallel. That is the only characteristic they have, and additionally their consecutive angles are supplementary. So the only thing that holds true, four-sided figure, one set of parallel lines. Isosceles trapezoid gets a little bit more specific. So they have the same properties up here, plus these additional ones. The non-parallel sides, these two over here, called the legs, they are congruent. The diagonals, the entire diagonals, are congruent. The base angles are congruent. So remember, in a isosceles triangle, we have base angles. So an isosceles triangle here, we have base angles that are congruent. We have the same thing here. So this angle here and this angle here are congruent. Additionally, opposite angles will be supplementary. So if this angle here and this angle here will be supplementary. So these add up to 180. And then we have this angle up here, which will be congruent to this base. Okay, so let's jump in. This first one I can tell is a regular trapezoid because this side is not congruent. So if angle J is 87, then I can say angle K will be alternate interior to angle L. So K and L, we have our parallel lines and the transversal. So K and L are supplementary. So to find K, I'll say 180 minus 51. So angle K should be 129. Now to find M, we don't have the base angles congruent. This is an isosceles. So I'll have to do the same thing here. J and M are consecutive interior. These are parallel lines. So I have to do 180 minus 87. So this should be 93. Okay, I cannot call M and L consecutive interior because they're both not on parallel lines. If these two sides were parallel, then I could. But as of right now, cannot be considered congruent. B, solve for x. So here we go. If I turn this, I've got these parallel lines, got my transversal. These two are considered consecutive interior. So I'm going to say these added up together equal 180. So 54 plus 8x plus 6 equals 180. Combine my like terms, 54 plus 6 is 60, so 8x plus 60 equals 180. Subtract 60, 8x equals 120. Divide by 8x equals 15. Oops. Just 15, not 150. Okay. This next one is an isosceles trapezoid. isosceles trapezoid. So we're just creating a congruency statement here. So DG, D to G. In an isosceles trapezoid, our legs, our non-base bases, are congruent. So DG is congruent to EF. Okay, and DF, this diagonal, is congruent to the other diagonal, EG. D, finding measurements here. So this is an isosceles trapezoid. So I know that our base angles are congruent. So angle W is congruent to X. So angle W is 47. I also know that with my parallel lines, I have this transversal of XY, and I've got alternate interior angles here. So angle Y is 180 minus 47. So angle Y is 133. Yes. And angle Z is base angles with Y, so angle Z and Y are congruent, 133 degrees. Example 2. So let's throw some more algebra in. It says, if MNOP is an isosceles trapezoid, so that means this is congruent to this, MP is 16x minus 13, NO is 9x plus 8, so those things we know are congruent because they are legs. Okay, and then we have PN, which is a diagonal, and MO, a diagonal. So we know that these things are congruent because diagonals are congruent. Then solve for x and y. So we just have two equations here, kind of two problems in one. So I'm going to have 16x minus 13 equals 9x plus 8. My other equation is going to say 5y plus 19 equals 12y minus 37. Pause the video and solve for x and y on your own. Okay, so subtracting 9, 16 minus 9 is 7x. Add 13, 8 plus 13 is 21, divided by 7, so x equals 3. Here, subtract 5, so 12 minus 5 is 7x, or sorry, this is y. Add 37, 19 plus 37 is 56. Alright, and divide by 7, so y equals 8. Number 8. If JKLM is an isosceles trapezoid, find the missing angles. So we're given some measurements here. I know that J and M are consecutive interior angles, and I know that consecutive angles are supplementary. So let's go ahead and say J plus M equals 180. 10x minus 33 plus 4x plus 17 equals 180. Combine our like terms. 10 plus 4 is 14x. Negative 33 plus 17 is negative 16 equals 180. Add 16 to both sides. 14x equals 196. Divide by 14, so x equals 14. Alright, so if x is 14, then I can go back in and plug it in. So I have 14 times 4 plus 17. So angle M is 73 degrees. If this is an isosceles trapezoid, that means angle L is 73 degrees. Okay, then for J and K, I can go ahead and say subtract from 180 and find both J and K, or I can just plug in 14 for X, so 10 times 14 minus 33, and get 107. If I add these together, I should get 180, and I do. So that just kind of double checks my answer. Both of those angles should be 107.